Friends, an electric iron is used in almost every home, and you must have used one as well. Today, with the help of 3D animation, we will understand how an electric iron works, how its temperature is set high or low by rotating the knob, and how it switches on and off automatically. From the inside, an electric iron looks like this. This part is the heating element. This is the neon bulb. This is the thermostat. And this is the thermal fuse. The heating element is the main part of the electric iron. Inside it, there is a heating coil made of nichrome metal. Nichrome is used because it has very high electrical resistance and can withstand temperatures up to 1,400 degrees Celsius without melting. To insulate the heating coil from the iron base plate, magnesium oxide powder is filled inside the heating element. Magnesium oxide is a good conductor of heat, but acts as electrical insulator. It prevents electric current from passing through and allowing heat transfer up to about 230 degrees Celsius, which is the normal operating temperature of an electric iron. If electric supply is given directly to the heating coil, it will keep heating continuously and we will not be able to control the temperature. To control this, a thermostat is used in the iron. The thermostat is fixed to the iron base plate, so it can sense the plate's temperature. When the temperature becomes too high, it automatically cuts off the power supply to the heating element. This is the input terminal of the thermostat. This is the output terminal. This is the bimetallic strip. And this metallic strip makes the electrical connection between the two terminals. The bimetallic strip is made of two different metals that expand at different rates when heated. For example, if iron and brass are heated to the same temperature, brass expands more than iron. If we combine these two metals into a single strip and heats, the strip bends toward the metal that expands less. This type of bimetallic strip is used in electric irons. When the iron's temperature increases, the bimetallic strip bends upward and pushes the contact strip. As a result, the connection between the input and output terminals breaks, cutting off power to the heating element. Once the power is cut, the base plate starts cooling down. As the temperature decreases, the bimetallic strip returns to its original shape, the contact is restored, and the heating coil starts heating again. This on-off cycle repeats continuously. Because of this, we hear a clicking sound from iron when this thermostat connection is made. The electrical connections inside the iron are as follows. The phase wire is connected to the input terminal of the thermostat, by which the current reaches to the output terminal of the thermostat. The output terminal of the thermostat is connected to one end of the heating element. The neutral wire is connected to the other end of the heating element, and the earthing wire is connected to the base plate. The neon bulb is connected between the phase and neutral wires to indicate power on. When we switch on the electric iron, current flows through the phase wire, passes through the thermostat, and reaches the heating element, causing it to heat. When the temperature knob is set to maximum, the base plate temperature rises. Near 230 degrees Celsius, the bimetallic strip bends and breaks the thermostat connection, and current flow stops. The iron then cools down. When the temperature decreases around 150 degrees Celsius, the strip starts coming in its original position and reconnects the circuit, due to which heating starts again. When the knob is set to a low temperature, it presses the contact mechanism in such a way that the connection forms and breaks more frequently. As a result, the iron does not heat as much. If, due to any fault, the thermostat fails and remains closed, the heating element will continue heating. This can cause the iron to overheat and it can catch fire. To prevent this danger, a thermal fuse is used after the thermostat. This fuse is placed on the heating element. When the temperature exceeds the value written on the fuse, this internal compound melts and breaks the circuit, stopping the power supply to the heating element completely. This protects our iron from fire and damage. I hope you found this video helpful. Please like the video and subscribe to my channel to support me. If you have any suggestions or compliments, feel free to write them in the comments. Thank you for watching.